Students, good morning. Day before yesterday, we discussed about adiabatic combustion process and adiabatic combustion temperature. Today, my question is adiabatic combustion temperature depends on the type of oxidizer? This is the question. Now, I am going to provide a brief information or answer for this question. With the combustion of methane, are we using an example of methane combustion? Using methane combustion, CH4 methane combustion. The answer for the question is yes. Definitely, the adiabatic combustion temperature depends on the type of compressor. Clear? Because each oxidizer have different heats of formation. First point, heat of formation. Second point, specific heat capacity. Third point, stoichiometric ratio on what number of moles of oxidizer used for combustion purpose. And fourth point is amount of heat released, whether it is completely remains in the production. Four important points. First point, combustion of methane by using fluorine. Combustion of methane by using oxygen. Combustion of methane by using nitrous oxide. Combustion of methane by using air. While you use fluorine as a oxidizer, it gives 4000 degree Kelvin adiabatic combustion temperature or more. This is highly exothermic. Or more. While use oxygen as a oxidizer for combustion of methane is used near about 3200 degree Kelvin. While use nitrous oxide as the oxidizer for the combustion of methane is used 2700 degree Kelvin as the final temperature. Instead of the 3, if you are using air, available abundant quantity in atmosphere, if you are using air as an oxidizer, it gives 2200 degree Kelvin. The answer for this question is yes. Adiabatic combustion temperature depends on the type of fuel or oxidizer. Because it depends on 4 important points. One is heat of formation. Second point, specific heat capacity. And third point, stoichiometric balance, stoichiometric ratio. Fourth point, amount of heat released. So different oxidizers have different amount of heat of formation and different amount of heat capacity. What is the moles of oxidizer used for combustion and amount of heat released during the combustion process? First, I am going to discuss about the fluorine as a oxidizer. First point, methane, combustion of methane using fluorine gives carbon tetrafluoride plus hydrogen fluoride. The stoichiometric balance 4F2 is equal to 2 times of 4H2 to 4HF. Clear? 4 into 8 fluorine, 4 plus 4, okay. Now it is balanced. Point number 1. This is highly exothermic. Reaction. Highly exothermic reaction and releases enormous quantity of energy during its combustion. Highly exothermic reaction. It gives enormous quantity of energy during combustion process. For point number 1. Point number 2. This combustion reaction does not have any non-reactive products. Non-reactive products. Non-reactive products. Non-reactive product means Say for example, if you are using air as the oxidizer, the role of nitrogen, the nitrogen is a non-reactive product. The role of nitrogen is it does not contribute any energy to the combustion process. It does not contribute any energy to the combustion process. Subsequently or contradictorily, it consumes certain amount of energy to its stability. So presence of non-reactive products significantly affects the total energy. So in this reaction, there is no chance for non-reactive products. Clear? Point number 1, it is highly exothermic. Point number 2, it does not has any non-reactive products. Point number 3, carbon tetrafluoride and hydrogen chloride both are stable components. Both are stable components. The bond between carbon and fluorine is highly strong. Similarly, bond between hydrogen and fluorine is highly strong. Carbon tetrafluoride is a refrigerant. It is called as R14 gas. R14 gas. Used as a refrigerant. Moreover, it is used for plasma etching in semiconductor production. R14 is called as refrigerant R14, carbon tetrafluoride. And additional information on carbon tetrafluoride is it is widely used for plasma etching for semiconductor production. Clear? So these two compounds are highly stable. So this is a brief information while you use fluorine as a oxidizer. What next? Oxygen. While you use oxygen as a oxidizer for combustion of methane, it produces near about 3200 degree Kelvin. The problem is molecular oxygen used or advised to use only for medical purpose, that means a respiratory purpose. Moreover, you should use exact stoichiometric amount of oxygen. If there is any deficit of oxygen, it causes to produce carbon monoxide. So in such a situation, you have to use excess oxygen for complete combustion of oxygen. It directly influences the cost. It directly makes the cost problem. Clear? So while you use oxygen as a oxidizer, it produces 3200 degree Kelvin as a adiabatic combustion temperature. What next? Nitrous oxide. Nitrous oxide. Nitrous oxide. If you are using nitrous oxide as a oxidizer, the additional information is before combustion process. Before combustion process, the nitrous oxide decomposes by itself. Just listen. CH4 plus N2O, nitrous oxide, gives carbon dioxide and water and nitrogen. Clear? This nitrous oxide will be 2N2 plus O2 plus energy. This is decomposition. Decomposition. Before participating the combustion process, methane is combusted by using nitrous oxide. Before combustion process, before participating in this combustion reaction, nitrous oxide will decompose by itself and produce nitrogen and oxygen and energy. This is decomposition energy. It plays major role in the total energy of the combustion process. It is additional plus information. Subsequently, the formation of nitrogen, what we call the reactive, non-reactive product, it consumes, it contributes nothing to the combustion process. Contradictorily, it consumes certain amount of energy from the total energy of the combustion process. It decreases the final temperature. It decreases the final temperature. Presence of non-reactive component. This is stoichiometrically balanced. That means 2NO2. Okay, 4 nitrogen, so 2NO2. Carbon 1 carbon, nitrogen, hydrogen 4 carbon, 2N2, and 2 oxygen 4. 4 times of 4 N2. Okay, what? This is 4 N2. When you increase the stoichiometric ratio, presence of nitrogen will be increased. It consumes enormous quantity of total energy during combustion process. This is the problem. It makes 2700 degree Kelvin final temperature. Clear? Again, one more information. If you are using oxygen, air as a oxidizer, again the presence of nitrogen plays an important role in decreasing the final temperature. So the answer for this question is adiabatic combustion temperature depends on type of oxidizer? Yes. Type of oxidizer plays an important role in deciding the adiabatic combustion temperature. This is the brief information on this question. Thank you.